Hello and welcome to this tech talk from Nordic Semiconductor here at Edge Impulse Imagine 2022. Today we'll talk about the fully self-contained embedded ML prototyping platform. My name is Robin M. Saltness. I'm a product marketing engineer at Nordic Semiconductor, and together we'll say hello to Thingy53. For the content of this tech talk, I will start off by something that's a little bit awkward, because I will talk about the problem of embedded ML prototyping. Luckily, I also have the solution to this problem, and I will walk you through the hardware of the NRF5340 SOC that powers this solution and all the sensors that this solution integrates. Then I will also walk you through the app that this solution uses to fully integrate into Edge Impulse Studio, and I will give you a live demo of this app in action. And lastly, I'll show you how you can progress beyond the testing, beyond the app and the demo, and tell you how you can get started on developing your own embedded ML solution. So let's jump right into it. What is the problem of embedded ML prototyping? Well, frankly, it's integration hell. Before you can start training your ML model, you'll have to integrate all the sensors you need into a hardware solution, a solution that you can use to gather data points to train your model on. And where does this come from? Well, for some sensors you can use your cell phone, and you can for instance use the microphone to record audio snippets and use them as your training data if you're doing a voice recognition ML project, for instance. But for some types of sensor data, this requires, for instance, you saving each sensor data point as a separate file and upload them separately to the Edge Impulse Studio. And this is labor intensive. And what if the sensor you want to sample doesn't exist in an internet connected device? Well, then you have to not only build your hardware solution and integrate that sensor into with a SOC or a MCU, you also need to find a way to get that sensor data from that SOC up into the cloud, into Edge Impulse Studio. And that's not always so simple. So you either have the option of doing a lot of manual labor, uploading one-on-one file, or you have a huge task of pre-developing a product just to be able to sample the sensors you want to use in your finished solution before you can even try out to make the ML model. So what is the solution to this problem? Well, say hello to Thingy53. The Thingy53 is a completely fully integrated embedded ML prototyping platform. It uses the NRF5340 system on chip as the brains of the operation. In it, we have integrated a well of sensors that can be used both to capture training data, but also be used at the input when you're running your embedded ML model. By using the NRF5340's built-in radio, we can connect the Thingy53 to our NRF Edge Impulse app that both uploads training data to Edge Impulse Studio and also downloads fully trained models back down to the Thingy53 after you built the model. And of course, no embedded ML prototyping platform would be fully self-contained without also being powered by itself. The Thingy53 has an integrated battery and is charged via USB-C. So this is some of the specs for the NRF5340 SOC. It is our flagship system on a chip. It's dual core M33 ARM Cortex processors. It has a high performance processor that runs on 128 megahertz clock speeds. This is typically where you would put your application if you were developing a firmware application for the NRF5340 SOC. This is where we will put the ML model, and the performance of this processing core allows it to run embedded ML models smoothly. It also has a highly efficient network coprocessor. That's also a ARM Cortex M33 processor, and we recommend that you put our tried and trusted protocol stack in this processor and leave the networking up to us, but it's fully open and programmable, so you can do whatever you want with this coprocessor. Then it comes to the multi-protocol radio. It supports Bluetooth LE, Bluetooth Mesh, Zigbee, Thread, and by extension Matter, and also less common standards like NFC and ANT. And paired with this powerful processor, we have integrated a wide variety of sensors. Here you can see the PCB layout of the Thingy53. It has a color sensor, it has an RGB LED, it has a digital MEMS microphone, it has user programmable buttons, it has accelerometer and gyroscope, it has environmental sensor that senses humidity, temperature, pressure and gas. It has an additional low power accelerometer, it has a magnetometer, and it has all the connection you would need to add any sensor that isn't already on the board. Because we have made this thingy the most extendable thingy yet. You have a USB-C for charging and also programming via the bootloader. We have a 4-pin JST accessory connector that's compatible with standards like Quick, Stemma or Grove, that utilizes a I2C interface. And then we have the 10-pin J-Link programmer port to upload firmware to your Thingy53. And then we have a Nordic specific debug and current measurement port. And out of the box, every Thingy53 is delivered with a debug and current measurement board that fits into this connector. And this connector will also be used for future accessories from Nordic Semiconductor. So the BME688 is the temperature, humidity, pressure and gas sensor delivered by Bosch. Bosch has also delivered the inertial measurement unit, which is the gyroscope and accelerometer. It has delivered they have delivered the magnetometer, and then we have a low power accelerometer, which is the analog devices ADXL362, and then we have the room BH1749 color and light sensor, and Vesper MEMS have provided the VM3011 digital MEMS microphone. So that's the gist of the hardware that we've integrated into the Thingy53. But we'll also developed some software. Together with Edge Impulse, we have developed the NRF Edge Impulse app to allow for dead simple integration with Edge Impulse Studio. The app is focused on making embedded machine learning easy, so every Thingy53 ships preloaded with the firmware to work with the NRF Edge Impulse app. The app acts as a bridge between Edge Impulse Studio in the cloud and your Thingy53 hardware, and it takes care of both data collection and downloading and deploying fully trained ML models on your Thingy53. So, how does this work? This makes Thingy53 the ideal platform for rapid ML prototyping. The app allows it to integrate seamlessly with Edge Impulse Studio, and you can use the Thingy53 both for data collection and for running your fully trained ML models. We download the firmware over the air and deploy ML models through the app. And low power has always been a key point for Nordic Semiconductor. We've been the masters in low power wireless for decades. And with the wake on event capabilities of the sensors, you can even make the lowest power embedded ML project humanly possible today with the Thingy53. So how does this work? Well, let's have a look at the circle of embedded ML prototyping. You start by sampling any sensor on the Thingy53. And once you have sampled a sensor, the app has already wirelessly transferred your sensor data into Edge Impulse Studio via your phone's internet connection. From there, you follow Edge Impulse's documentation and you build your ML model. And once that ML model is built, it's already available for you to download and deploy via the app back to the Thingy53. Then you can use the app to start inferencing, meaning running the ML model on the Thingy53's NRF5340 SOC, and just reading out the outcomes of the inferencing, the results on the phone's screen. All the processing is being done on the 5340 SOC, but you use the phone's display as a HMI, as a human interface, to see what the decisions of the ML is. And this is a circle because once you've done this once, you can collect more data, you can have them uploaded to the cloud, you can build your ML model again, and this way you continuously improve upon your model until you have a model that you're happy with. Okay, so let's do a demonstration of how easy it is to get started with machine learning on the Thingy53. So here I've logged into the NRF Edge Impulse app. If you don't have an Edge Impulse Studio account, you can easily create one from the app. I'm already logged in because I don't want to share my login credentials with you. And here's a brand new Thingy53 in its box. So let's just unbox one. And keep in mind, this is a brand new Thingy53. I haven't downloaded any firmware to it. I haven't made any modifications to it. This is how it comes straight out of the package. So let's just power it on. And you can see it comes to light with a LED flashing different colors. It shows up in the app as Edge Impulse. We connect to it with one click, and then you can go in into the thingy, and you can see all the info on it. You can see its connected status, and you can see all the info on all the sensors it has, and you can see the maximum sample length for each sensor, and you can also see the sampling frequencies that sensor supports. So you can see the accelerometer sensor, the microphone, the initial measurement unit, the light sensor, the environmental sensor, and you can also have combinations of sensors. You can have the inertial and the light sensor sampling as one. You can have the inertial and the environmental sensor, and you can have the light and environmental sensor. And this firmware actually also comes preloaded with a ML sample. So if we go directly to inferencing, we can actually start inferencing right away. And this is the continuous motion sample ML project. So you can see now it recognizes the motion of laying idle on my desk. And if I do a little snake with the thingy, you can see it recognizes snake. I can also do the up-down wave, and it recognizes this as up-down. And I can do a regular side-to-side wave, and it recognizes that with a high level of confidence, and it shows the high level of confidence in a green text color. Okay, and this is well and good. We have now confirmed that the thing is actually working, and it's communicating with the Edge Impulse app. But this isn't that impressive, because we also want to integrate with our online Edge Impulse Studio account, right? And so since the thingy has all these sensors integrated, we want to take advantage of them, and we need some way of getting sensor input up to our NRF Edge our Edge Impulse Studio account, and we can do that through the app. So if I, for instance, want to change my project into the responding to my voice project, I just change it in the app. And if I want to add a data sample to train on, I just click the little plus. Seems like my thingy has disconnected. I'll just reconnect. Okay. So if I want to add a sensor sample, a data sample to train my sensor on, I can click the little plus. I can select the label, and for this demonstration, I want to say hello to the Thingy 53. So hello Thingy will be my label. Let's do that again. Hello Thingy will be my label, and I will select the microphone as the input device. I will set down the sample length to a couple of seconds, 3 seconds, 2 seconds, and then I'll start sampling. Hello Thingy. And it's completed the sampling, and it's receiving the firmware, and it uploads this sample to Edge Impulse Studio. And if we log into our Edge Impulse Studio account now, we could see that this data sample is already available to build our model in Edge Impulse Studio. It's that easy. So for one sample, this isn't a big deal, but to make this a good ML model, you will have to have tens, maybe hundreds of samples. And if you have to repeat a manual process of collecting these with, say, your phone as a data file, and then uploading that single file to your Edge Impulse Studio account, that's a lot of work. With this solution, it's really, really simple. But that's not all. Now, let's say we have collected all these samples with the app. We go into the the Edge Impulse Studio account, and we build our ML model following their excellent documentation. And then we want to deploy it back to the thingy. How do we do that? Well, it's easy. It's very easy through the NRF Edge Impulse app. So you just click on the build. You confirm that you have the correct project, and then you build it. And you see it builds the sample, it downloads the ML model from the cloud, and it flashes the firmware with this correct ML sample to your Thingy 53 over Bluetooth LE. And this isn't sped up in any way. This is how fast it is to update a model. So now you see it's already applying the update and confirming that it's complete. You can see the Thingy rebooted. That actually means that the update is complete. Now it's just verifying. So in a couple of seconds, it will say complete and success. And there you have it. That's how easy it is to have an ML to gather data and upload them to the Edge Impulse Studio cloud, and also download fully trained models and flash them to your Thingy device for inferencing. And if you go back to the inferencing tab now, we can start inferencing, and if I had collected enough samples and actually built this model now, we could have had Thingy react to hello world and show us with what level of confidence it recognizes between hello world and hello Thingy. And now I know some of you will be saying, Robin, so what? This isn't development. This isn't, you're not building anything. You're just testing out your hardware. You're just building an ML model based on some samples, and you're not using this ML model to control anything or to make any decision. You're just showing us a confidence interval, and it's not really doing anything. And you're correct. There's still a lot of development that has to be done to make this a useful ML application, but that's up to you. But luckily, Nordic Semiconductor's vision is to make the life easy for developers. So of course we will help you with this as well. And this is why you start developing in NRF Connect SDK. The NRF Connect SDK is our software development kit. It's built on the Zephyr RTOS, and it comes with batteries included, meaning everything is already integrated into the Zephyr RTOS, so you can just pick out the components you need and place them into your application firmware, and it's ready to go. And it's hosted by the Linux Foundation. It's fully open source, but Nordic is a huge contributor to Zephyr, and in the NRF Connect SDK we actually have our own fork of the entire Zephyr project, meaning if there's breaking bugs in the main branch of Zephyr, Nordic will have a stable branch in the NRF Connect SDK no matter what. The Thingy53 is supported in NRF Connect SDK versions 2.0.0 and later. It has hardware driver support for all its sensors in this SDK and many existing compatible firmware samples. When you have developed your own firmware based on one of our samples or from scratch, you can flash this firmware via an external debugger, for instance a Nordic Semiconductor development kit, or to the USB-C bootloader, or over the air device firmware upgrade through the NRF Connect for Mobile app. So to summarize, the Thingy53 has the processing power for edge computing and embedded ML, and all sensors necessary already integrated. It integrates seamlessly with Edge Impulse Studio through the NRF Edge Impulse app. And if you need to use a sensor that isn't already integrated, we have a connector for connecting that sensor on external hardware. And as a bonus, you will get the option to develop your custom solution in the NRF Connect SDK. And with that, I say thank you for your attention and have a wonderful evening.